Okay, so yesterday we talked about simplifying radicals that just have numbers underneath the radical sign. And today we're adding to that. You can see here where we're going to have numbers and variable terms underneath the radicals. So just kind of remembering yesterday that we talked about the inverse operation piece, or that they undo each other in terms of exponents and radicals. So if I had the square root of 5 squared, which is really the square root of 25, it's just going to bring me right back to 5, or that these undo each other. So the same is true if I were to take the square root of a variable, square root of x squared. These are going to undo each other and leave me with just x. Now, of course, we're not always going to just have x squared. You can see we have x to the 6th here, y to the 18th here. So there's kind of a bigger idea here that you explore further in Algebra 2. But to give you a basic sense of what's happening here, when I have the square root of x squared, a square root or any root, we can really write as an exponent. We're not going to dive too deep into this, but instead of writing square root around it, I could actually raise it to a fractional exponent, to the 1/2 power. And we talk about this in an Algebra 2 course. But to kind of give you a basic idea on what's happening when we simplify with variables, if we go back to properties of exponents, right? P-man, we would, power to a power, we would be multiplying there. And 2 times 1/2 just gives me x to the 1st. And so this idea helps us understand how we simplify with radicals, which is really going to be that we're going to take whatever our exponent is and divide it by whatever the index is, okay? I'm going to take the exponent and divide it by the index of the radical, and that's going to tell me if I can evaluate that variable term or not. So when I have the square root of x squared, 2 divided by 2 gives me x to the 1st. If I had the square root of x to the 4th, well, 4 divided by my index of 2 gives me x squared. Okay, really I'm just dividing that exponent by whatever the index is. But if I had the square root of x cubed, well, that doesn't work. 3 cannot be divided by 2, okay? It is not divisible by the index. Okay, now when that happens, we do similar to what we do when we simplify radicals, right? So these are really like our perfect squares. This is not a perfect square. I can't evenly take the square root of x cubed. So we use the product property. Okay, just like when we said the square root of 50 is 25 times 2. Okay, so that's 5 rad 2. We can take the square root of 3 and break it into 2 factors and then 1. I still have 3 factors of x there, but just like I broke 50 apart, I'm breaking x cubed apart. And then I can take the square root of this, it's x, and I cannot evaluate just the square root of x to the 1st. And that here's my simplified version of what I started with. So we are still simplifying with variables, and the concept is the same, where we're taking that radicand and we're breaking it apart into things we can, in this case, divide by 2, and things that would be left over. Okay, so I think this will become clear when we look at a few problems together. So these first ones are pretty direct, and they're going to simplify really nicely, and then we're going to look at things that won't simplify as nicely. So remember, we're always looking at that exponent value and seeing, can we divide it by the index, and then what's the result of that? So square root of x to the 6, well, 6, this is an index of 2. 6 divided by 2 is x cubed. I've simplified it. Okay, done. Nothing, there's no kind of breaking apart that needs to happen there. This time, my index is 3. Okay, it's a cube root. So as I'm going through and simplifying with these variables, I'm no longer saying, well, what is it divided by 2? This is square root, so I'm going to divide it by 2. Here, I'd say, well, can it be divisible? Is it divisible by 3? So x to the 6, if I divide that exponent by 3, gives me x squared. Y to the 18th exponent divided by 3 would give me y to the 6. 12 is also divisible by 3, so 12 divided by 3 gives me z to the 4th. Now I've evaluated that cube root. And we could have done the same. Let's just do a different problem. What if it was the square root of x to the 6, y to the 18th, z to the 12th? This is also going to work out perfectly for us, where they're all numbers that are divisible by, in this case, 2. So instead of x squared, now I'm taking 6 and dividing by 2 gives me x cubed. 18 and dividing by 2 gives me y to the 9th. 12 divided by 2 gives me z to the 6th. So here's a cube root of x to the 6th, y to the 18th, z to the 12th. And here's the square root of the same variables. Okay, but what the index I'm dividing by is different. It's going to give me a different result. And we can have numbers in here too. So 64 happens to be a perfect square. The square root of 64 is 8. Square root of x squared would be x to the 1st. Square root of y to the 8th would be y to the 4th. Now the last one is an example for when we get a little further down in math, but here, these are inverse operations, and we looked at this on the notes yesterday. So if I have this parentheses squared underneath the square root, these are just going to undo each other and leave me with just a cubed plus 4. Just kind of a good thing to keep putting our eyes on, that it doesn't have to be, it's not always going to look exactly the same as a problem like this. This also is going to be an inverse operation, or exponent divided by index. So now let's look at a few that don't work out quite so nicely. So I'm going to look at 8, x to the 7th, y to the 15th underneath a square root. So first of all, 8 is not a perfect square. So I'm going to take 8 and I'm going to break it apart, right? And 8 would be, I'd be looking at 4 times 2. So I'm going to say, well, I can evaluate the square root of 4, and the square root of 2 is going to stay inside my radical. And notice I left a gap here, and that's to go down through my other terms. Okay, 8 is 4 times 2, which simplifies, gives me 2 rad 2. When I get to x to the 7th, I can't take 7 and evenly divide it by my index of 2. So similar to how I broke apart 8, I'm going to break apart 7 into 6 times 1. And so I take the largest number of factors of x that I can out. And so just like I could evaluate the square root of 4, I can take the square root of x to the 6th. That would be x cubed. I can't take that additional factor of x out, so it's going to stay inside. For y to the 15th, so thinking I have 15 factors of y here. 15 is not divisible by my index of 2, but I can factor this into 14 y's and then 1 additional y. I can take the square root of y to the 14th. 14 divided by 2 would give me y to the 7th. This has to stay in my radical. And here's my simplified rad. 2x cubed y to the 7th, square roots of 2xy. That is my answer. Okay, we're out here. Those are all the things I can take the square root of. Here are all the things I could not. That would be left behind inside my radical. So let's look at another one. Flip this over. So now let's look at a cube root. Cube root of 24, x to the 11th, y to the 4th, z to the 9th. Okay, and same idea, I'm going to go term by term. So starting with 24, I can't take the cube root of 24, but I can break 24 into 8 times 3, which is helpful to me because 3 is a perfect cube. The cube root of 8 is 2, leaving me with this factor of 3 inside my radical. Exponent divided by index. 11 is not divisible by 3. So I need to break x to the 11th into what I can divide by 3, what's the most I can take out, and what would be left behind. And so x to the 10th also not divisible by 3. So I need to break this into 9 factors of x, and then there'd be 2 more, making up the 11 factors altogether. And the reason I choose 9 is because 9 is the largest exponent value I can grab there that's divisible by 3. 9 divided by 3 would give me x cubed when I evaluate that, take the cube root of it, and it's leaving me with x squared inside my radical. Y to the 4th, 4 is not divisible by 3. So I need to break it into what I can divide by 3, which would be 3 of those factors, and what would be left? The cube root of y cubed would be y to the 1st, or just y, leaving me with y inside my radical. And then my last term, z to the 9th, is a perfect cube. I can take 9 and divide it by 3. So the cube root of z to the 9th is z cubed, 9 divided by 3. And here's my, I'll rewrite it. So this is all the stuff I could evaluate, leaving inside the cube root 3x squared y. Here's my answer. So let me write another, this time I'm going square root. So square root of 50, x to the 4th, y to the 5th. You may want to pause that for a minute and think about, well, what would I do there? Giving the first 2 problems as an example. And so 50, not a perfect square, but I would break into 25 times 2. I can take the square root of 25, right? Square root of 25 is 5, leaving me with the square root of 2. That's exactly what we were doing yesterday. Then I go to my exponents and I see, can I divide the exponent by the index of my rad? My index is 2. I can take the square root of x to the 4th. I can take all of that out. 4 divided by 2 gives me x squared outside my radical. I can't evenly divide 5 by 2. So I'm going to break this into what I can divide by 2 and what would be left. So 4 factors and then 1 more. Y to the 4th divided by 2 gives me y squared outside my radical. And this additional term of y has to stay inside my square root. And there's my answer. Let's look at another square root. Square root of 52 x to the 7th y, z to the 11th. And again, I would pause the video and see, well, what would I do here? How would I approach this? And I would say, well, 52 is not a perfect square, but it is 4 times 13. So here's my perfect square factor of 4, gives me 2, leaving 13 inside my rad. Can't evenly take square root of x to the 7th. So I'll break it into 6 and 1. And I can take the square root of x to the 6th. 6 divided by 2 would give me x cubed outside my radical, leaving this x in. I have y to the 1st. I can't take the square root of that evenly, and I can't break it apart. So this is just going to go, it's going to stay in my radical. No breaking apart, nothing I can do there. Can't divide 11 by 2, but I can break it into 10 times 1. 10 is divisible by 2 would give me z to the 5th, leaving me with z to the 1st inside my rad. Okay, now one more cube root. So let's do the cube root of 64, which is a perfect cube, by the way. A to the 21st, b to the 60th, c to the 13th. So cube root. Don't be like, Don't get so caught up in simplifying you don't identify when you have a perfect square or a perfect cube given to you. The cube root of 64, this is a perfect cube, is 4. 21 can be divided by 3. I can take all of that outside of my radical. It's going to give me a to the 7th. 60 can be divided by 3. I can take all of that out. Is going to give me b to the 20th. 13 can't evenly divide by 3. So I got to break it into what I can divide by 3, which would be 12 of those c's, leaving me one behind. And the cube root of c to the 12th would be c to the 4th outside my rad, leaving me with a cube root of c inside my radical. So now I'm going to give you a few to try before we're done for today. So I'm going to take this exact same thing. I'm just going to give it to you in a different form. So instead of a cube root, what if it was the square root of 64? A to the 21st, b to the 60th, c to the 13th. How does that change things? Okay, so that's the first one I want you to look at. Then let's see, let's do 75 x squared y to the 7th. And let's do the cube root of 32 x to the 6th, y to the 13th, and z to the 20th. So take a moment and write those down. And then I want you to pause the video, do them all the way out, and then I'm just going to show answers. I'm going to show all my work, but show you the answers to those. And just be careful, this is a cube root, not a square root. First two are square roots. Okay, so let's see what we have here. So when this becomes a square root, I have to break apart a lot more terms because 21 is not divisible by 3, or sorry, divisible by 2, and either is 13. Okay, and here's my final answer on that first one. Second one, I have to break apart the 75 and the y to the 7th, but x squared I can take out evenly. And then when I get to this cube root, again, I have to switch to a different set of numbers. So 8 times 4 is what I'd break 32 into. Cube root of 8 is 2. And then here you guys can see circled what I can evaluate. And this z to the 20th, I need to go z to the 18th, and z squared is what would be left behind because 18 is the most I can evenly divide by 3. And there's my final answer there. And you'll get more practice with this in our next kind of practice set of homework as well.